this assessment, we're asked to predict the product of this sequence of reactions when applied to this ketone. The sequence will start with the addition of an acetylide anion, which as a strong nucleophile can directly attack the carbonyl. That results in the formation of an alkoxide that we can then quench in an acid quench step. That will complete the synthesis of a tertiary alcohol. At this point, we can do hydroboration of the terminal alkyne, and we won't show a full mechanism here, but when we hydroborate the terminal alkyne, we first make this borane intermediate, where the hydrogen and the boron add on the same side of the alkyne. Treatment of this borane intermediate with sodium hydroxide and hydrogen peroxide is going to replace that carbon-boron bond with a carbon-oxygen bond, or a carbon-hydroxyl bond. And so that would give us this product initially, or this intermediate initially. This intermediate that we formed is an enol, and that enol will tautomerize spontaneously to give us an aldehyde. Let's number our carbons to make sure we have this right. We'll call this one carbon 1, carbon 2. Then we get to the hydroxyl group at carbon 3, carbon 1, carbon 2, carbon 3. That makes us feel comfortable that we have the product right. This hydroxyaldehyde is the product of this sequence.